Okay, optimisation is one of the hardest C2 topics. It's just stationary points. That's all it is. It's just stationary points. But the only difference is the stationary points that we usually do have x's and y's, and we're given the equation. So all optimisation is a lot of the equations involve things like volume and area and radius and height. So it's using different variables other than x and y. That's confusing in itself. And the second thing is often you have to create the equation that goes into the bird. All right, so that's why it's harder. Okay, now the questions often have quite a lot of words in them. So we are mathematicians. We don't do English. I hate the words. So what I'm going to do is I'm going to get rid of these words. Now, the first thing that I'm going to do is I'm going to say to myself, what's the question? What is the question? Now, there's a little bit of stuff here, all right? There's a little bit of stuff there, and there's a little bit of stuff here. And I've got to decide which one of these is my question. Now, my question is this one here. What is the maximum volume? So we start building up an equation with the thing that I think is the question. So I'm asking for the maximum volume. I'm going to ignore everything else. So I'm going to start to create an equation for the volume of this cylinder. Okay, the volume of a cylinder is just a prism. So it's just the area of the cross-section, which is pi r squared, times the height of the shape, which is h. So the volume is pi r squared h. Now, often in exam papers, they will say, show that the volume is this. And what you'll find is that the volume will only have one letter in it. Now, my volume doesn't have one letter, it has two. It has some R's in it and it has some H's in it. So what we're then going to do is we're going to work with the other piece of information. Okay, the second piece of information looks like this. What they're actually telling me is they're telling me that the surface area is 600 pi. So I'm often saying to myself on this second part, they're telling me something. What are they telling me? They're telling me something that I've obviously got to use. So what I now do is I'm going to build up a second formula. This one is going to involve the surface area. So what's the surface area? It's two circles. So two lots of pi r squared. That's my two circles. And then this is like a baked bean tin wrapper. So if you unwrapped the wrapper, can you see that this length over here, the length of that rectangle will be 2 pi r. That's the same as the circumference there of the circle times h. And of course that's just a rectangle. So it's base times height. The base is that and the height is that. Okay, what do I know about the surface area? The surface area is 600 pi. So I'm going to put that in. And then I'm just going to see if I can simplify this. Okay, there's a pi in everything. So I'm going to get rid of the pi. What will that leave me with? And then I think I'm going to divide everything through by 2. So I'm going to be left with 300 equals, so let's divide that by 2, equals r squared, divide that by 2, plus rh. Okay, I'm going to bring back my volume equation from before. Now my volume equation was V equals pi r squared h. So that's my volume equation. So I've got him as a volume equation, and I've got this one as my surface area equation. So what I'm going to do is, we talked about wanting my volume equation to be in one variable or one letter only. And I'm going to see if I can get rid of the h and have the volume equation just in terms of r. Now, quite why I do that is because I want it to be in one letter, and often in the exam paper they will say show that the volume is this. So they will often give you a bit of a prompt that they want it in only one letter. So what I'm going to do is I'm going to try and get rid of these h's by using this formula here. So let's fiddle around in here. So 300 minus r squared equals RH. I've just moved him over the other side. And therefore h is 300 minus r squared over r. And therefore it's just simultaneous equations. And I'm going to substitute that into here and see what I end up with. So volume equals pi r squared times h, which is 300 minus r squared over r. And now I'm going to, that r will cancel with one of those r's. So v equals pi r 300 minus r squared. And then we're going to times that out. So v equals pi, in fact let's write the 300 first. V equals 300 pi r minus pi r cubed. And that is now my formula for my volume. That's just the first bit. That is just about creating the formula. Now what I find is that if the question said, show the volume is this, a lot of students panic and then they give up on the whole of the rest of the question. And I'm going to say this to you repeatedly. If you can't do this first bit, you don't give up on the next bit, because the next bit is just stationary points and it's worth millions and millions of marks. So the question was to try to find the maximum volume. That was my question. Find the maximum volume. Okay, this is just now stationary points, and we're going to do the bird. All right, we're going to do this bird. Okay, so going into here is instead of y, it's a v, and instead of y's and x's, it's just v's and r's. So I've got v equals 300 pi r minus pi r cubed. So Stella's bird says the next thing we're going to do is we're going to do dy by dx, except it's not dy by dx, it's dv by dr. So there's nothing different. Okay, let's differentiate this. R is to the 1 and 300 pi is just a number. So 1 times 300 pi gives me 300 pi. Okay, and differentiating this bit gives me 3 times pi is minus 3 pi r squared. You'll get used to doing those. The next bit of the bird is the second derivative. So it's d2v by dr squared. And if we differentiate 300 pi, well, 300 pi is just a number, so it will disappear. And then when we differentiate this bit, we should get minus 6 pi r. Okay, the bird says, let's move my bird over. The bird says that we are going to do this bit, the beaky bit of the bird is going to be my dy by dx is 0, or in this case dv by dr is 0. And therefore then we're going to put him on. Do the bird. There he is, birdie bird. Okay, right, let's actually do some solving. So what we're going to do, let's move him up here, is we're going to solve this bit here of this bird. We're going to solve dv by dr equals 0. So 300 pi minus 3 pi r squared equals 0, because let's have a bit of a think why we're doing that. That's my stationary point. That's where my stationary point or my turning point, that's where the gradient is 0. So in fact, I'm wanting a maximum, aren't I? I'm wanting it to look like this, a maximum turning point. Okay, so I'm going to move this over to the right-hand side. So he'll become 3 pi r squared. I'm going to take away the pi's or divide by pi, and now I'm going to divide by 3. So I'm left with 100 equals r squared. So r, if we square root 100, is 10 or minus 10. Now, often what happens in these questions is you have to be a little bit clever. Right, can r possibly be minus 10? No, we can't have a radius of minus 10, so we reject it, and therefore my answer is r is 10. I don't know what units I was using, centimetres, millimetres, who knows. Now the question said find the maximum volume, and the maximum volume is this bit up here, isn't it? It's like the y value. So to find the maximum volume, the volume is 300 pi r minus pi r cubed. Okay, so let's feed our r into here. The volume equals 300 pi times 10 minus pi 10 cubed. So my volume is 3,000 pi minus, what's 10 cubed? Minus 1,000 pi. So I reckon the volume is 2,000 pi. And I don't know what my units are. Maybe if it's centimetres cubed. Okay, the next thing, of course, they might ask you to do, let's move him back up again, is they might ask you to determine the nature or prove he's a maximum turning point. So in terms of determining the nature, we're going to go for this third bit of the bird. Here's the third bit of the bird. So we're going to look at the second derivative, d2v by dr squared equals minus 6 pi r. So we had r as 10. So when r is 10, we're going to feed it into the second derivative, which gives us minus 6 pi times 10. And minus 6 pi times 10 is minus 60 pi. We have to make a statement whether it's positive or negative. I don't mind what you write. I tend to write that, but I'm happy with you writing negative, and I'm happy with you actually writing the word negative. I don't actually care, but we have to write that statement. And therefore it's a negative. It's the way you think it isn't. So therefore it's a maximum turning point. And that's it, guys. That's optimization. It's just stationary points with a little bit of harder stuff. Harder at the beginning because you've got to create the equation, and a little bit tougher because the letters are V's and R's. But that's it. It's just, oh man, it's all moving. It's all moving. Do the bird. It's all right. It's just do the bird.